Okay, we're going to talk about increasing and decreasing. We've already discussed this a little bit, so this is a bit of a review. So let f be a function defined on the interval, and let a and b be any 2 points on the interval. Then the following is true. If f is increasing, then the y-coordinates from are going to be less than each other. If f is decreasing, the y-coordinates are going to be, the first y-coordinates will be greater than the other. And suppose f is continuous interval from a to b, it's also differentiable. If the derivative is greater than 0, then f prime is positive, then f is increasing. We talked about that. If f prime is less than 0, that means f prime is negative, and f is decreasing. So let's look at a couple examples. The derivative g prime of the function is continuous and has 2 zeros. Selected values of g prime are given in the table below. If the domain of g is the set of all real numbers, then g is decreasing on which intervals? Which ones are they increasing? So remember, when we talk about decreasing, decreasing means g prime is negative. That would be where g is decreasing. G is increasing, where g prime is positive. So let's find values, where first let's do decreasing. While g is decreasing, it looks like I'm going to go from my 0 to my 0. And if you look, above it are my actual values. So I have decreasing to decreasing here. But I need to have my starting point. So it starts decreasing at the 0. So going from negative 2 to positive 2. So I'm going from 0 to 0. So we have g is decreasing from one x-intercept to the next. So from 2 to 2. This is interval notation, not the 0.22 or negative 2, 2. G is increasing where my function is positive. Notice my function is positive at this value and at these values. Again, you have to include where your x-intercepts are. So g is increasing from negative 4 to 2, and that's what the u means, from 2 to 4. Please don't just include, a lot of you guys are going to just do this, you're going to say it's these values I'm highlighting in blue, and you're going to forget to go to your x-intercepts. Please don't do that. Please make sure you include your x-intercepts. Number 2, we're going to use our calculator. We're going to graph g of x is equal to x to the 4th minus 8x squared plus 1, and g prime simultaneously. Identify intervals where g is increasing and decreasing, and we're going to justify. So let's go ahead and plug in. So we have x to the 4th minus 8x squared plus 1. And then the bottom one, I'm going to do n deriv, so math 8. Then vars, y vars, y1, comma x. And I'm going to scroll over so I can see the difference. And I'm going to make my derivative more bolded. So I'm going to hit enter. It's not doing which one I want. There we go. And hit graph. And just like we worked in our lab before, you'll be able to see where is your function going to be increasing and or decreasing. So areas where your derivative are positive are going to be above the x-axis. Areas where your derivative are negative, it's going to be below the x-axis. So again, positive means your function's increasing. Values for your derivative below the x is where your g is decreasing. Alright, so let's go ahead and get those x-intercepts. I want to clear this. I'm going to go back to y, and I'm just going to turn this off so we can see it better. Go back to graph. And I just want to find my x-intercepts, or my roots. So second calc, 0. Get this first one over here. Left bound, right bound. Oops. So negative 2. My next one's looks like it's going to be at 0. Yep, 0. And oops. I think I have 2 again. Yep, 2. So on my x-intercept are going from negative 2 to 0 and positive 2. So from negative infinity to negative 2, my function is decreasing. So g is decreasing. From negative infinity to negative 2, and looks like from 0 to 2, because, and this is where when they ask you to justify, you would write g prime of x is less than 0, or you can write or is negative. Alright, g prime's positive. So g is increasing, where g prime is positive. So we're increasing from negative 2 to 0, and from 2 to infinity, because g prime is positive. It's greater than 0. Number 3, using the graph below, determine the intervals where g is increasing or decreasing. Notice that I gave you g prime, which means you can't look to see where the function is going up and down. That's not what I'm asking about. I'm asking where's the function negative and positive. So let's look at the values where g prime is positive. That means values above the x-axis. Well, it looks like I'm looking at value, g is increasing from, looks like negative 3 to infinity. Let's go ahead and deal with this right here. Notice I have a 0 right there. We'll say we're going from 2, because technically at 2 it's not really positive or negative, and then we're going from 2 to infinity. Now let's do decreasing. That means g prime is negative. Well, it's negative down here. So g is decreasing. from negative infinity to negative 3. Alright, so let's justify our answers. So this is the part that most students forget. So we have g is increasing from our interval, and that's because, I'm going to do BC for because, g prime, that's what they gave you, is positive. For my decreasing, g is decreasing, again there's my interval, I'm going to do BC for because, g prime is negative. And that's what they're looking for.